Welcome to this episode of the CompTIA Tech Plus Prepcast by BareMetalCyber.com. Let's begin. Network services make it possible for devices and systems to communicate, share information, and collaborate across local and remote environments. Each service operates using specific protocols and port numbers that define its behavior and ensure that devices from different manufacturers can interoperate reliably. The CompTIA Tech Plus exam includes coverage of these core services, focusing on web browsing, file transfers, and email. This episode explains the purpose of these services, how they work, and how they connect to network devices. Hypertext Transfer Protocol, known as HTTP, is used to deliver web content and normally operates on port 80. The secure version, HTTPS, uses port 443 and applies encryption using Secure Sockets Layer or Transport Layer security. Web browsers use these protocols to request, display, and submit content from web servers. HTTPS is required when transmitting sensitive data such as user logins, payment details, and other private information to ensure confidentiality and integrity. File Transfer Protocol, known as FTP, allows the uploading and downloading of files between two systems. It operates using port 20 for data transfer and port 21 for control commands. Standard FTP does not encrypt data, which means information such as credentials can be intercepted. The secure version, known as FTPS, adds encryption using Secure Sockets Layer or Transport Layer security, and is often used for website maintenance, backups, or distributing system updates. Secure File Transfer Protocol, abbreviated SFTP, runs over port 22 and uses the same encrypted channel as Secure Shell. This protocol encrypts both authentication details and file data, making it more secure than standard FTP. SFTP is also more firewall-friendly because it uses a single port, making it a preferred method for administrators moving configuration files or performing secure backups between systems. Email communication depends on several protocols working together to send, receive, and store messages. Simple Mail Transfer Protocol, or SMTP, sends messages between mail servers and typically uses port 25 or port 587 for secure submissions. Post Office Protocol version 3, or POP3, retrieves messages and downloads them to a local client using port 110 or port 995 for the secure variant. Internet Message Access Protocol, or IMAP, keeps messages on the server for access from multiple devices and uses port 143 or port 993 when secured. Web-based email services such as Gmail or Outlook.com deliver messages using HTTPS directly through a web browser. Client-based email software such as Outlook or Thunderbird uses POP3 or IMAP for retrieving messages, while still relying on SMTP for outbound delivery. Both web-based and client-based methods require correct server names, ports, and authentication credentials to function properly. Secure browsing relies on Secure Sockets Layer or Transport Layer security certificates to authenticate websites and encrypt communications. A valid certificate presented by a website allows browsers to show a lock icon and establish a trusted connection. Certificates that are expired, self-signed, or issued by an untrusted authority trigger warnings in the browser. Certificate authorities issue, validate, and revoke these digital credentials to maintain trust in online communications. File sharing inside a local area network is often done using Server Message Block, abbreviated SMB, or Common Internet File System, abbreviated CIFS. These protocols allow users to open, copy, and modify files on shared network drives. Microsoft Windows uses SMB natively, while Mac OS and Linux systems can connect to SMB shares using built-in tools. File servers may be general-purpose systems or dedicated network-attached storage devices, with access permissions controlling which users can open specific files and folders. Network printing services allow multiple users to share printers over a network rather than connecting directly via cable. Print servers coordinate jobs from different clients, manage printer queues, and track usage. Internet Printing Protocol, abbreviated IPP, and Line Printer Daemon, abbreviated LPD, are common standards for sending print jobs to network devices. Printers can be discovered automatically using methods such as Domain Name System Service Discovery or Bonjour, or they can be added manually using an Internet Protocol address. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Many network services rely on centralized authentication and directory systems to manage user credentials and permissions. Lightweight Directory Access Protocol, abbreviated LDAP, and Microsoft Active Directory are common examples. These systems store account information and control access to files, applications, and network resources. Authentication protocols such as Kerberos, Remote Authentication Dial-in User Service, abbreviated RADIUS, and NTLM verify identity and authorize access. Centralized identity management helps maintain security, simplify administration, and enforce consistent policy. Domain Name System, abbreviated DNS, is used to translate domain names into Internet Protocol addresses. For example, entering google.com into a browser triggers a lookup that returns an address such as 142.250.72.206. Client systems use resolvers to query DNS servers which respond with the correct address. Caching DNS results speeds up repeat lookups, but failures in this process can prevent websites or services from being reachable. Dynamic Host Configuration Protocol, abbreviated DHCP, automatically assigns Internet Protocol addresses, subnet masks, gateways, and domain name system settings to devices. This reduces manual configuration work and minimizes address conflicts. When a device connects to a network, it requests an address from the DHCP server, which issues a lease for a set period. Leases can be renewed or reassigned based on network policies. Firewalls play a key role in controlling access to network services by allowing or blocking specific ports and protocols. For example, rules may permit secure web traffic on port 443, but block file transfer protocol on port 21 or Telnet on port 23. Restricting unnecessary services helps reduce the attack surface. Administrators adjust these rules based on organizational needs and security policies. Network Address Translation, abbreviated NAT, converts private internal Internet Protocol addresses into a single public address for communication over the Internet. Port forwarding is a related function that directs incoming traffic on specific ports to designated internal devices. This allows access to services such as web servers or camera systems without exposing the entire network. Proper configuration is essential to maintain both access and security. Internet of Things, or IoT, devices such as printers, cameras, and smart appliances often connect directly to networks. Many host web interfaces for management and monitoring, but each must be assigned a secure Internet Protocol address and configured with strong credentials. Default passwords or open ports present serious security risks if not addressed. Some networks use service discovery protocols, such as Bonjour or Multicast Domain Name System, abbreviated MDNS, to allow devices to automatically advertise and find available services. This eliminates the need to manually enter Internet Protocol addresses when connecting to printers or file shares. While convenient for home or small office environments, such features should be disabled in enterprise settings to prevent unauthorized discovery. Troubleshooting network services often involves identifying misconfigured ports, incorrect domain name system settings, failed authentication, or service outages. Common diagnostic tools include Ping for basic connectivity, NSLookup to verify domain resolution, Netstat to view active connections, and Telnet to check port accessibility. Reviewing server logs for file, email, or web services can help pinpoint issues, and restarting affected services may resolve temporary failures. On the exam, you may encounter questions requiring you to identify the correct protocol for a given service or recall the default port number it uses. Scenario-based items may describe failed email delivery or an unreachable website and ask you to determine which service is misconfigured. Being able to match services with their protocols and ports will help in both test performance and practical troubleshooting. Key terms for review include HTTP, HTTPS, FTP, SFTP, SMTP, POP3, IMAP, SMB, DNS, DHCP, IPP, NAT, and port. Organizing these terms by categories such as file transfer, email, web, and system services can aid in retention. Practice recalling their port numbers, use cases, and the protocol layer they operate in. In real-world environments, IT support specialists are frequently tasked with configuring email clients, setting up shared printers, and ensuring file access is secure and functional. System administrators monitor and secure service ports to prevent unauthorized access. Remote workers depend on the correct configuration of these services to maintain productivity. Understanding the structure and flow of network services improves both troubleshooting speed and security posture. This concludes the discussion of network services. In the next episode, we will examine how different network types and models operate, including local area networks, wide area networks, client-server architectures, and peer-to-peer designs. You will learn how to identify where services operate, how networks are organized, and the role of each device within them. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.